Hi, everybody. In this video, we are going to be looking at 11.1a, problem number 8, where we have a pyramid that we're answering questions about. So let me share my screen. Actually, I want to show my whiteboard. Okay, so let's get a picture of a pyramid going here. And the picture, it says, use the following drawing of one of the great pyramids of Egypt with a square base to find the following. So we're going to draw the first base. And I need to put on a square base. Just a second. Sorry about that. Oh, good, it's still here. Now let me put on the points. Okay, point B. Back here in the back, it's point C. Here we have point E. And at the apex of the pyramid is point B. Okay, so first of all, we're supposed to name the intersection of segment AD and CE. So here's AD and here's CE behind it. Now we're told that the base is a square. What do you know about the sides of a square?
They're parallel.
They're parallel. So will AD ever intersect CE?
No.
No. So that first question, we would just put the empty set. That's impossible. Next, we need the intersection of the planes ABC, ACE, and BCE.
Oh, they intersect at C.
Okay, so, plane ABC is this one off to the left-hand side of the pyramid. ACE is the base, the plane with the base. And
I'm
BCE
sorry.
is the plane in the back. So you're right, they intersect at point C. So our part A was the empty set, part C was just the point C. And that's something you can visualize in the room that you're in, or you can look at the room that I'm in even. If you look at, I'm gonna stop sharing my screen so you can look at the room that I'm in.
Okay.
Can you see, there's the plane of the ceiling, there's the plane of this wall, and there's a plane of the back wall. So they all intersect at just one point right there in the back. You see that?
Mm-hmm.
Okay, that's a picture of it. 3 points intersecting at just one point in space.
Okay, that makes it definitely clearer to visualize. So,
Now on the pyramid that we just looked at, you know, the planes were angled differently than in this room. In this room, we've got, well, it's actually in this room, we don't have just perpendicular planes. Actually, the ceiling is slanted. It's perpendicular on the two walls, but the ceiling is slanted. So,
okay, so it's
Um,
still hits at that same point, right?
yeah.
Okay. All right. That, yeah, I'm looking around me here and I see that I have quite a few of those as well.
Yeah, so it's kind of interesting that these three huge structures, planes that go on infinitely, actually are intersecting in just one point.
Yeah, that surprised me a little bit as well.
Yeah. Okay, so next, the intersection of line AD and line CA. So here's line AD, here's line CA. So where are they intersecting? Those lines
At point A.
would be point A. So part C, the answer is point A. And we name points in geometry with a capital letter. Part D, a pair of distinct parallel lines.
Well, now first was a pair of skew lines was number D. Was
Oh,
letter
the
D.
skew and E is parallel. Okay. Skew, the lines never touch, but they're not in the same plane. So they're not necessarily parallel. They're not parallel. So we need to find some lines that would not be in the same planes. So like you could have segment AC and segment BE.
Oh, got it. Okay, so AC and BE.
Yeah, there's more than one answer on that one.
Yeah, because it could be AD and BE,
Yes, it could be. Uh-huh.
DE and CB. Oh, right, DE and CB.
Let me read you the actual definition of skew lines. It's on page 665 in your book.
Oh yeah, I looked
Skew
that up.
lines are lines that cannot be contained in a single plane. They are non-coplanar. They're not, they can't be in the same plane.
Okay, all right, that makes that easier to see. Okay, good. Yeah, I can see that there can be quite a few answers on that one.
So one of your potential answers is AD. If you looked at line AD, notice when you name the line, you put two little arrows in it. And the line indicates it goes on forever. But even if it goes on forever, these two are not going to intersect.
Okay.
We're not in the same. It's kind of interesting.
And then for the parallel lines, that's clear because you've got the square base, right?
Yeah, right. Which mine turned out, regular than square, so I apologize for my drawing. And then F, a plane not determined by one of the triangular faces or by the base.
Yeah. One of the triangular faces.
So on this one, I'm going to use dashed lines so you can kind of see it better. You can look at the plane that goes through AB, or sorry, AE, and also through the point B. So the plane BAE kind of cut, it slices right through that pyramid, but it's not lying on any of the triangular faces or the face.
So now so I'm confused by that. So is it because you were able to connect 2 points?
So a plane is set out by 3 points. So there's a plane that can go through those points, B, A, and E, but that plane won't coincide with any of the triangular faces or the rectangular base. It's just cutting right through. It's slicing through the interior of the pyramid. So if I do it on my hand, here's the base. You can think of this being the base of the pyramid where my hand is. And now I'm going to slice right through.
Okay, yeah, I mean, I can visualize that. I did, what I was confused is how you took the point from A to E, like how you could do that, but now you said since the plane was determined by the 3 points, now that makes more sense because I couldn't figure that out. So you're just connecting 3 points that don't have part of that.
They're not part of any of the triangular faces and not part of the base.
Oh, okay. That one, that was a one that was very confusing for me. Okay.
Okay, now we've already talked about how 3 planes can intersect in a point, but I want to show you how 3 planes can intersect in different ways. So first of all, if I just have a sheet of paper, I can show you how 2 planes intersect. I'm just going to fold my sheet of paper here. So if I take my sheet of paper and I fold it, now you can see there's 2 planes here and here, and they intersect in what object are they intersecting on?
On a line or
A line. Yeah, on a line. Now it's possible that you could have a 3rd plane or even a 4th that goes through that same line. See how we could have the 3rd plane going through there?
okay. Uh-huh.
It could intersect in that same line, but there's other ways that planes can intersect. So I want to show you this. It's really cool. Okay, here's a picture of 2 planes intersecting in a line.
Oh, okay.
Okay, there's a picture of 3 planes
Okay.
intersecting a point. I'm gonna put 3. I want to show you 3 in a second. Okay, see this picture?
Uh-huh.
There's 3 planes intersecting.
Okay, I see that.
There's 3 planes that are parallel and they don't intersect at all.
Never intersect. Okay.
All right, here's 3 planes, kind of like a paddle wheel, intersecting in a line. They can intersect in a line, they could not intersect at all. They can intersect in 2 lines, they can intersect in a point.
Oh.
There's a better picture of it even, how they're intersecting in a point.
Okay.
You could have all 3 planes being together on top of each other. Or you can have 2 planes together and one of them not the same. Or you could have the 3 planes in a triangular shape intersecting in 3 lines. See that?
Oh, wow. Yeah, I wouldn't have dreamt that one up.
Yeah, so the intersection of 3 planes it's kind of fascinating. So I wanted you to have that visual because you might have questions about that in the homework.
It reminds me of this, like putting together like paper airplanes, like
Yeah.
back in the old days, like when it would all fit in perfectly.
Yeah.
Yeah. Okay. Yeah, that definitely makes the plane part easy, way